Welcome back to our course on industrial organization. Last week, we started our discussion of the monopolist's quality choice. What we looked into was, as a first problem, the question: if the monopolist produces just one product, which quality will she choose? In the next step, we will look into the case in which the monopolist provides several products, and we ask the question under what circumstance she will really produce more than one product. But for the moment, we just go back to our case we discussed last Tuesday, when we had this very simple setup, and I just want to show it here, where we had a simple demand curve which took into account that our consumers have some willingness to pay for quality, and this willingness to pay for quality was uniformly distributed over some interval. Probably you do not see, probably I should change the color so that I have a different one from last week, so that we have an interval from 0 to theta, where theta is both the total number of consumers, or the measure actually we would call it, and also with this I times z determines the maximum willingness to pay for the product. And what we saw is that this gives really rise to a very simple demand curve. Once we have this demand curve, we are always happy, because once we have a demand curve, we can set up our profit function here. Okay, we are just here, revenue is determined here, of course, by both the price and the quantity, and here we just use the price as an inverse demand function, and we had here the choice of the quality. We assume that marginal costs are 0. The simple problem would, or the simple solution would be just taking the derivative. I already wrote that down last week. With respect to the two variables we want to choose optimally, that is both the quantity and the quality C. And what we get is we get some optimal price and some optimal quantity. And in the second step, so that was already what we did last week. And in the second step, we determined what the optimal quality level is the monopolist chooses. Okay, that's pretty much where we ended last week. And my cliffhanger was, in a sense, the question whether, okay, the monopolist chooses a certain quality level. Is that quality level, from the viewpoint of total wealth or total surplus or social welfare, the optimal one? Or does the monopolist underprovide or overprovide quality? And that's what we are going to look into right now. And I want to do that in terms of a diagram. And look into that into the terms of a diagram. We already saw that this is just our demand curve we have in this case. And with a low quality level, what we determined was that the optimal price is just this quality level times theta over 2. Simple monopoly price, A plus C over 2. Remember, C was marginal cost was 0, and Z times theta, or C times theta, is just the maximum willingness to pay. So simple monopoly price. And now what we get here is this rectangle, which is just the increase, this rectangle here, this green one, which is just the increase in profits if the firm increases its quality level from C1 to C2. Okay? Now the question is, what is the monopolist, or the social planner's increase in total surplus, given we provide this quantity here? Okay, we know, of course, the optimal quantity would be theta, because marginal costs are 0, but we assume, or we just look into the second best solution, where we take the output as given and just ask the question, given that output, what kind of quality would a social planner choose? And what we see here, this is just gross consumer surplus. So this is gross consumer surplus or welfare in the situation in which we provide low quality C1. Now, if we provide the high quality C2, this is a gross consumer surplus, and the change in gross consumer surplus is just this green trapezoid. And what is immediately clear is that this green trapezoid is larger than the rectangle, which is just the increase in profit. So what we have as a result is that the increase in total surplus is greater than the increase in profit, and therefore the monopolist underprovides quality. It provides too little quality. Okay, that was what we can immediately derive in terms or by means of this diagram. Of course, we also can show that formally. The only thing we need, and I go back to my red color here, the only thing we need is gross consumer surplus. You're well aware of that. This was just this trapezoid, or this, or whatever it is, the area, the whole area below the demand curve, and this whole area below the demand curve is just this expression. Okay, you just can check it by looking into the rectangle and the triangle we have. And what we are doing is just we want to look how that gross consumer surplus changes if we marginally increase quality. So we take a derivative with respect to C, and we get straightforward Q times theta minus Q squared over 2. Now what we enter here is our second best welfare measure. Okay, so we want to evaluate that at the point where we have the output of the monopolist. So we take the monopolist's output decision as given, and what we obtain here is 3 times theta squared over 8, and this would be then or would have to be set equal to the marginal cost of quality, which is somewhere up here, would have to be set equal to marginal cost of quality in order to derive the optimal quality level of the social planner. But it's already sufficient to show that the planner chooses a higher quality than the monopolist, because this increase in gross consumer surplus, which is nothing else than the increase in total surplus, is higher, larger than the marginal revenue in terms of quality of the social of the monopolist. Okay, 3/8 for larger than 2/8. Okay, and so what we see, and this is now the formal proof, that our monopolist underprovides quality. It chooses a too low quality level, and that's what we typically also would guess. What our intuition is. Remember the quality level of railway, of state-owned railways, or of privatized railways, even, where we always had trouble in the United Kingdom, for instance, in terms of their quality level. Okay, so that's the first result. The other question is it possible that quality is too high, that the monopolist chooses too high a quality? And you will see that is only possible under rather particular circumstances. And here we go back to our situation where remember, this was the case where the inframarginal consumer, I want to show you that the increase in quality rotates the demand outward, starting at this vertical intercept. This was just a case where the marginal consumer had a higher increase in willingness to pay due to the quality increase than the inframarginal consumer. Remember, this was your second car for the poor, for the rich, and the main car, the only car for the poor. This was my example. And what we need to further assume here is that our monopolist does not change its quality due to the change, does not change its quantity due to the change in quality. Of course, it's clear if we would draw here the marginal revenue curve, you see immediately, take this as a marginal revenue curve for this demand curve, you immediately see that the monopolist would increase her output. Okay, so in order to solve this somehow nicely, we assume that the monopolist is restricted to this output level. What comes to mind here is, for instance, this situation we had in the 1980s in the United States, and President Ronald Reagan forced Japanese car exporters to the US to voluntarily restrain their exports. So they had a restriction on their exports. Okay, so the quantity was given, and the question is, what does that imply in terms of their quality choice? What we see here is, again, we do the same thing as we previously did. Given we produce this output cube lower bar, the increase in profit due to an increase in quality from quality level C1 to C2 is this dark blue rectangle. The increase in terms of social surplus, remember the change in gross consumer surplus, is just now this triangle, and what is obvious is that this triangle is now smaller than the rectangle, and the incentive of the social planner to increase quality is lower than the incentive of the monopolist. The monopolist overprovides quality. The monopolist produces too much quality. Okay? Why the monopolist only is interested in the willingness to pay of the marginal consumer. The marginal consumer's willingness to pay increases a lot, even though the gain for the other consumers is rather limited. Okay, and that's what we typically see if we have some kind of restriction on quantities, like in this case of export quotas. The point is that these Japanese producers just produced rather high quality cars and tried to export them. Okay, so this is rather hopefully straightforward. We have a problem in the assignment on that, and I think you can discuss that if there's any questions about that part. If you have some direct questions, this is what we have here in terms of this quality choice. Now we want to move on and look into the case in which a firm just not simply produces only one quality, but remember our BMW example, we have different qualities we offer. The question is then, under what circumstance do we offer more than one quality? Okay, what parameters determine whether we produce more than one quality, and which qualities do we choose? Do we choose rather extreme qualities or rather similar qualities? Our first model is a rather simpler one, very closely related to our discussion we had above in the price discrimination section. So what we assume is that we have two quality differentiated products, a high quality and a low quality, for instance, and we have only two types of consumers. Each consumer has a unit demand. Okay, and suppose, and this will become even clearer in a little problem in the assignment, our indirect utility of a consumer of type I is just this theta. You know that already, and we have two different consumer type. One type has a high valuation of quality, the other has a low quality valuation, and then quality matters. Okay, higher quality means higher willingness to pay, but in a sense we have some lower bound on the quality, which would be a minimum quality level. So if you're a rich guy, the minimum, and you think about buying say a second or third car, you have a certain idea of the minimum quality level this other car should have. Otherwise you just have a willingness to pay of zero. So you probably wouldn't be satisfied with a Fiat 500. And of course that will be different, because the poor guy will have both a lower willingness to pay for quality, a lower valuation of quality, but also a lower bound on quality. It might even be zero as long as it's a car who is working. Okay, it might be rather a base level. And in the example, you will see just put some numbers here, and it's rather straightforward in terms of how to derive what then the indirect utility is. Okay, now here what we did and what I made here anyway in terms of this assumption, this minimum quality level can be assumed to be zero for the guy who has a low valuation of quality. And assume also that the marginal costs are zero for both quality. So the difference here is not in the production cost, but in the fixed in the product development cost. And you have some type N1 and N2 of consumers of each type. the solution procedure here is similar to that of second-degree price discrimination. You have an incentive compatibility constraint, you have a participation constraint. You do exactly the same thing, and you will have to do that in the assignments in one of the problem sets. And what is interesting here, and I don't go into the details here, I just want to mention this result. You will be able to derive that. Remember, in second-degree price discrimination, if we had many high valuation types, our result was that we only serve these high valuation types. Okay, we have then our golf club or our gourmet restaurant, which has very high prices and serves only the high valuation type. Here it's different, because if we have many high valuation types, we offer both products, but otherwise we offer only the high quality product. Why is that? Because the high quality product, if we offer the high quality product, the willingness to pay of both types increases. So in terms of our optimization problem, we tend to always want to offer the high quality because that increases willingness to pay. But the point is, of course, if there are many high valuation types, we really want to charge them a lot. And therefore, if we want to sell it to the low quality type as well, to the guy with a low valuation, we cannot increase the price as much. So if we can use the introduction of the second lower quality as a price discrimination device here, okay, that's pretty much what it is. The high price for the high quality can be reached by choosing a rather low quality level for the low quality good. That's another point in terms of what kind of qualities do we want to choose. So if we have here a very low quality level of this second product, the high willingness to pay guy would never buy this very bad or very poor corn. Okay, so no more discussion of this here. This should become then very clear in terms of this assignment, in terms of this problem, because it's straightforward in terms of the procedure and similar to second-degree price discrimination. Rather than going into detail, I just want to introduce a slightly different model, which is somehow the workhorse model and which we already introduced, where we have many consumer types, as we had previously. Assume the monopolist has a choice to produce two different qualities, a high quality set 1 and a low quality set 2. And assume that the good quality, the high quality BMW costs you more to produce than the lower quality. Okay, that doesn't sound so implausible. And now, as we previously had, our indirect utility, we again have our consumers, which are uniformly distributed over 0 and theta. And simply each consumer's willingness to pay is just depending on his or her index I times this quality level and minus the price that we charge. Now, what we have to determine now, if two qualities are offered, is which quality will a consumer buy? And of course, that will depend on both the quality level and the prices of these two products. And what we already know from our discussion, for instance, of the hoteling model of spatial competition, or of the spatial model, of locational model, we want to look at the pivotal or at the indifferent customer. And we want to look at this customer I who is indifferent between the two qualities. And this customer is indifferent between the two qualities if the indirect utility from quality 1 is the same as the indirect utility from quality 2. And simply this just means that I times Z1 minus P1 is equal to I times Z2 minus P2. I think this can be wonderfully illustrated here in terms of this diagram. On the x-axis, on the abscissa, I draw all the consumers in increasing value of of the willingness to pay of this index I, and of course the maximum number of consumers is theta. So we have along this line all consumers, and along the x-axis, the y-axis, along the ordinate, we depict this indirect utility. Now, this would be the indirect utility from consuming product 1 for some consumer I. If we look at the consumer I with the index 0, her willingness to pay would just be simply minus P1, because she gets a 0 utility from consuming the product, as the index I is 0, so her utility would be minus P1. Up here, of course, for this consumer theta, the utility would be just theta times Z1 minus P1. Okay, it becomes hopefully even clearer if we do the same or draw the same line for the indirect utility for all the different consumers I for product 2. Again, here, for the consumer with the index I equal to 0, the utility would be minus P2. And now what we see here clearly, the blue line has a lower slope than the red line. A lower slope because the slope here is nothing else than the quality level C1 or C2. Okay? And now we already have a wonderful result. Why? Because we see here, as I drew this, we have an intersection. And of course, if we look at this consumer I here, this consumer I is indifferent between the two products, the two qualities, because the indirect utility is the same. For the consumers at these price levels P1 and P2, the consumers to the right of I have a higher willingness to pay or a higher indirect utility from product 1 than from product 2. So all these consumers will buy product 1. Okay, product 1. And of course, now the consumers to the left have a lower utility from product 1. They will buy product 2, but only here, of course, if their indirect utility will be larger than 0. Okay? And of course, this determines another pivotal consumer. It determines the consumer I lower bar, which is the last consumer who buys. And of course, again, it gets too crowded. All consumers in this range here, they won't buy anything given these prices. Okay? So we have two segments, hopefully clear. And the first segment here, I just use different colors or use the text marker. The first segment is this here, where all these guys buy the high quality, these guys here buy the low quality, and these consumers here with the very low valuation of quality don't buy anything. Okay, that's what we get. That hopefully should be clear, and you see directly in terms of our diagram what we already did and what we could do here formally. We just solved for I, and we see that I is just P minus P1 minus P2 divided by Z1 minus Z2 immediately. So if P1 increases, I will increase. What does this mean? I increases. Now, what the demand for high quality is straightforward, because everyone between theta and I buys. So Q1 demand for quality 1 is just theta minus I. And if P1 increases, if the price 1 increases, what is clear, demand goes down. If P2 increases, the I will decrease and demand will go up. Now we are happy because we already have our demand function here for the high quality. Okay, remember, if we have a demand function or a demand curve, inverse demand function, we always can set up our profit function and can just take a derivative and get immediately our profit maximizing choices. Okay, so that was it here. What I do in the next year, what is determined, of course, and what I showed you here, where I already derived the I lower bar. The respective condition, as I told you already, is that the indirect utility is 0, and of course in the case I drew, it's just here for product 2. And what we saw if we solve this is just that we get I lower bar is equal to P2 over Z2. And of course, what we have to check is if you write down the quality, the demand for the low quality, it would be just I. Again, going back, this is just our green range here. This is between I and I lower bar. And of course, this demand is only positive if I lower bar is smaller than I, okay? And of course, here we have a condition on I lower bar, it's P2 over Z2. Here we had a condition on I, and it just holds that I lower bar is smaller than I if P2 over Z2 is smaller than P1 over Z1. Okay? And now if we were in the lecture hall, in a classroom, I just would ask you, why does that make sense? What is this? Is that a sensible condition? Is that an intuitive condition? It tells you, oh, what is this? This is nothing else than the quality adjusted price of product 2, and this is the quality adjusted price of product 1, of the high quality and the low quality. And what does this tell us? The quality adjusted price, or let me put it differently, the low quality is only demanded if the quality adjusted price is lower than that of the high quality. Can we give an even nicer example? Yeah, think in terms of batteries. Suppose you have two different batteries. One has a battery life of 2 years, given some standard usage. The other has only a battery life of 1 year. Okay, it works only, or light bulbs to anything. And of course, the point is, so the quality adjusted price of this battery with the only 1 year must be at most 1/2 of the price of this battery which lasts 2 years. Okay? And this hopefully makes sense. You would never buy a battery which lasts 1 year if its price is more than half of the 2 year, because after 1 year you have to buy the second. And of course, you still will buy the high quality probably if its quality adjusted price is higher, because you only have to go to the shop once every 2 years. Okay? Here you already get the idea why you might have a higher willingness to pay for quality if you have more money. You just don't want to go to the shop so often here in that respect. Okay, so hopefully this has become clear. Now we have our demand functions, and we just can set up our profit function. Now what we have here, this first highlighted expression, this term is simply Q1, which is nothing else than our theta minus I. So this would be just our I. So the quantity times price minus per unit cost. So this would be just per unit profit. The same for product 2. Here the quantity of product 2. Again, this is nothing else than our I, and this is nothing else than our I lower bar. Okay. So you see, once we are able to derive our quantities, our different consumers, we immediately can derive the demand functions, and then we can set up the profit function. And of course, now the problem is simple, because we just maximize the profits by choosing, given that we have the qualities Z1 and Z2 of our products, we just choose the optimal prices. Okay? We choose the optimal prices, and you should check, and hopefully we have a problem in the problem set. You should check whether this is true, but as you will see in a minute, it's rather plausible. Price 1 for the high quality would be 1/2 times C1 plus Z1 times theta. What does this mean? Remember, this is just the maximum willingness to pay for the quality. This is just as in our standard example where we have a linear demand with a vertical intercept of A. This is just A plus C over 2. standard monopoly price. And the same for quality 2, okay? Standard monopoly pricing. That's what you see here. You get this. Then the question is, of course, what do we get in terms of our eyes and of our demands? This is a bit tedious. I just substituted that. What is interesting, of course, here is the next question. Under what circumstance will we sell two products at all? Okay, under what circumstance is I lower bar lower than I? And this holds only, and of course you have to just solve for that, set these two equal and then solve. This holds only if Z2 if C2 over Z2 is smaller than C1 over Z1. Okay? Again, does it make sense? What is this? What is this C2 over Z2? What is this C1 over Z1? Actually, this is just the quality adjusted cost. This is the quality adjusted production cost of the two products. And again, think of the batteries. A monopolist would never offer a low quality battery if it costs more to produce. Again, take the 2 years and the 1 years. If the 1 year battery costs more than 1/2 of the 2 year battery to produce. Okay, that should make sense, because she would get out less in terms of quality from the product. Okay, that's it. So in a sense, the monopolist offers a low quality product only if its quality adjusted production costs are lower than those of the high quality product. And of course, that makes sense also in efficiency terms. And that's why the social planner uses the same decision rule. So here we have an efficient decision in terms of the quality level. And what we could do, of course, in a next step, and I don't know whether we have a problem on that, would be interesting, is we could endogenize this choice of the quality of Z1 and Z2. So for instance, like what we did in economics of innovation, suppose our low quality Z2 is some base quality level which we normalize to 0, and of course the firm could produce a higher quality by investing in some research and development cost, and would then increase the quality level Z1. Okay, and the question is, under what circumstance would our firm produce two different qualities? Again, we would assume, suppose we have our BMWs. What it's clear is that the 7 series has higher production cost than the 1 series. And the point is, we offer both different product lines if the production costs increase more than proportionally with quality. Okay, only then we also offer the low quality product in this setup. That's similar, or this is in a sense an expansion of this condition here. Okay, because this leads to something like the fact that the quality adjusted costs of the low quality are then still lower than for the high quality if the quality costs increase more than proportionally, or if the production costs increase more than proportionally. Okay? Well, that's about what I wanted to tell you here, I think. Hopefully this was clear. Again, we will have, I think, a rather nice problem set in order to understand that. What we can also look into in order to go back once again to our price discrimination setup and quality. So what we have here, what we already saw, perhaps I should move that discussion here to what I had here discussed already in this other case. It would fit better to this case. Anyway, I already presented that. So the point is, why would we have a low quality? Okay, or what is the optimal decision in such a price discrimination setup? Of course, what we already had in these other cases, we extract all consumer surplus from the low quality good. We use here screening device, we set a high price for the high quality goods, so that of course the incentive compatibility constraint for the people with the high willingness to pay is satisfied. Okay, so what that means is we can of course only charge a high price if we have a high quality. So what I actually already, I think, discussed in the case of price discrimination is, which is of course more natural to in terms of the interpretation here in terms of qualities. So if you have actually a simple or single quality, like say you developed a product which is called Mathematica, okay, very nice software for doing computer or a computer algebra system, so to do all your nice calculations. You, of course, what you do in terms of, due to cost reasons, you just develop the full version. Okay, what you do then is, you have people with different willingnesses to pay, and what you're doing in order to also be able to serve it to the people with the low willingness to pay, call them students, you just what is called crimp that product. You, in a sense, produce a low quality product by damaging the high quality. So you just disable some functions in your software. Similar for MATLAB, and I already think I told you this example of the Intel processors of the 486 and 4SX and DX lines. Okay, again, this is very similar to what we did before. Okay, so I think you already should have got some idea on this quality differentiation, quality choice and quality differentiation, and what the decisive parameters are. You saw this important condition that the quality adjusted cost, or the quality in terms of the monopolist, must be lower for the low quality so that it's offered at all. Okay, and also the decision problem of these consumers. And I think hopefully it was clear to you that this is a rather nice illustration of this problem. I think I'm done with this discussion of the quality choice and of vertical product differentiation here. And before I move on to discuss what is called bundling, I just want to make a short break and ask for questions in the YouTube, in the WebEx chat. You're welcome back. Now we start our discussion of bundling. What is bundling? Actually, bundling could be treated as a known topic, but actually it's a part of, or a version to do price discrimination. What does it mean? So typically many firms sell products as bundles. If to go to the cafeteria in our Mensa at the university, you very often get meals which consist both of a dessert, of a main course, and of a salad or something like that. If you want to buy software, you cannot even buy just a Microsoft Word. You have to buy the whole Office bundle. Okay, I think Microsoft no longer serves individual software packages or programs just like Excel or Word. You have to always buy the bundle. In terms of TV channels, you typically can only buy bundles. So I have cable TV, so you only can buy bundles where you have, I don't know, 50 or 60 different channels included in these bundles. So why are firms doing this? Actually, in order to price discriminate, as you will see, in order to extract consumer surplus or willingness to pay from consumers which are somehow heterogeneous and have different willingnesses to pay for the different products. So what is bundling? You sell two or more goods in a single package. Like, oh, this is outdated. No one has, rather than me, has a stereo today, a stereo system. Another interesting point here is what is called tie-in sales, which we will briefly discuss at the end of this topic here, of topic of bundling. This is less restrictive than bundling. It just means that you tie the sale of one good to the purchase of another. Think of the example we already discussed when we discussed a two-part pricing or two-part tariffs, where we have the computer printer, and in order, if you have these Euroden Packard laser printer, you can only, for a long time, could only use Euroden Packard printer cartridges. It's like bundling because you bundle these two together, but it's different from bundling. That's why it's tying. You, of course, such a bundle typically consists of one unit of one thing and one unit of the other thing, whereas here you buy one printer but might buy several printer cartridges. Okay? We will get back to that later. You might also use or constrain the use of spare parts. You can only use certain spare parts for your Volkswagen, for instance. And why are companies doing that? Companies doing that because it's profitable, and that's what I'm going to show you in the next 45 minutes. Okay, our first example of bundling. It's a rather famous example. It goes back to a paper by Georg Stiegler, University of Chicago, industrial organization economist. And he had this example. So you are a Hollywood studio, and you offer your Hollywood films to TV stations, okay? And suppose we make a very simple package or bundle. It consists only of two films. It's Casablanca and Son of Godzilla. You know Casablanca, these Ingrid Bergman, Humphrey Bogart classics, high culture and so on, whereas Son of Godzilla is more like trash. And so you sell them to two different television stations. Station A or Station A, call it Arte, okay? This French-German cultural channel. Of course, Arte will have a high willingness to pay for Casablanca, but a much lower willingness to pay for this trash film, Son of Godzilla. The other you call, if you're German, you call it Tele 5, Tele 5, okay? Where they sell, broadcast, I think they have even time of the week where they broadcast the worst movies ever. And of course, they have a higher willingness to pay for this trash Son of Godzilla, but a lower willingness to pay for this classic Casablanca. And what you also assume is that arbitrage is possible between the stations. That is, what you sell as a Hollywood studio is just the right to broadcast this movie one time or two times or three times. And if you sell the right to Arte, it might pass at a low price, it might pass it on to Tele 5. Okay, that's what you have. Okay, now therefore, you have, if you want to sell it to both, you cannot sell Casablanca to Station A at a price of 8,000 and at a price of 7,000 to Station B, to Tele 5. Okay? So what happens now? How much can be charged for Casablanca? If you want to sell 2 units, if you want to sell it to both stations, you can only charge 7,000. And of course, you can only charge 2,500 for the Son of Godzilla. Of course, then you sell 2 units of each, so 2 times 7,000 and 2 times 2,500 gives you a total of 19,000, given the marginal cost of 0. This is pretty much your operating profit here. Okay? The question is then, could you do better if you bundle these 2 films? Actually, that's, I don't know what Kirch's first name was. There was a media mogul, we would call it in German, who sold packages. Leo Kirch was his name. Perhaps you look him up. He's already dead. He was, I don't know, some 10 years ago he died. But he became rich by buying movies in the US and selling them bundles to German and European or the movie rights in the US and selling these bundles then to European TV stations. Okay, now why is it a good idea to sell bundles here? So suppose you bundle them. What is the total willingness to pay of Arte for the package for this bundle of 2 films? It would be 10,500. What is the total willingness to pay of Station B of Tele5 for these 2 movies? It would be 10,000. So the aggregate willingness for the 2 gives a higher profit, as there is this negative correlation between the willingness to pay for the 2 different products. So you can charge now, of course, 10,000 for the product, and you will be able to sell both. And 10,000, 2 times 10,000 is 20,000. So you increase the profit here by bundling. Okay. Because we have this, in a sense, negative correlation between the two products. Okay, bundling is profitable because it exploits this aggregate willingness to pay. One firm is willing to pay only little for one movie and more for the other, and vice versa. So what you use is this total willingness to pay, and that's what you really are able to extract or make use of if you bundle. Last year we had Joel Waldfrogel from the University of Minnesota, who is rather famous in terms of digital goods and the analysis of these kind of digital products. He gave a talk here in our research seminar, and he gave a rather related example here. Bundling in a digital age. Now it's not more these TV stations, now it's streaming services like the Netflix and like the Spotify. And the point is, what is the rationale behind these bundled subscription sales of these certain products, these digital products, which are of course special in that they have zero marginal costs. Okay, so why don't you pay for each song which you download or stream from Spotify, or for each movie or series which you watch at Netflix? Now, and this is pretty much the same what we just have, bundling and profits. This is a mini lecture he gave here in a sense. Suppose you have 2 consumers and 2 songs. How much can I make by selling these songs separately? So you have a Lola, and close to you I even have to look up is an old-fashioned song from the Carpenters. Highway to Hell, of course, you know, is AC/DC. Lola obviously seems the tougher of the 2 here. She has a higher willingness to pay for Highway to Hell than Max, and it's different here. And what is clear, if you sell them separately, so if you make them sell for each of the 2 products, if you want to sell these close to you, sell it only to Max, you can charge 120, but you make only 120. If you charge 70 cents, you make 140. And given that your marginal costs are 0, the point is that it's good to sell to both at the low price. Similar for Highway to Hell. Again, you want to sell it at the low price of 80 cents, of the lowest willingness to pay here, and you make 160. So 140 plus 160 is $3 you make from these 2 consumers. Now, how much can you make by bundling? What would they be willing to pay for a subscription where we get all these songs? They would be willing to pay their aggregate willingness to pay 170 Lola and 2 here. And now you can sell, of course, you would not sell the bundle at $2 because that would give you only $2. If you sell it at $1.70, you make $3.40, and $3.40 is better than $3. And what Joel's conclusion was that it took a while, but it has worked for a long time. These kind of streaming companies try to charge you by song, but now they just selling you bundles. Okay, and you really can make or extract or make use of this aggregate willingness to pay. And now it's even more so. I have a bundle subscription or family subscription of one of these services. Now it's even more complicated because my family's willingness to pay for the different products differ largely, I have to say. Okay, hopefully this simple example was clear. What is interesting now is what we might introduce is cost here. Here we, for the minute, we assume that these are products which with marginal costs of 0. But remember your menu you get in the cafeteria, the salad certainly, even though it might not be of the highest quality, it certainly causes cost for the cafeteria, for the Studentenwerk. Okay. And here you might think of mixed bundling. What is mixed bundling? You offer both the bundle and you offer it separately. I don't know if you want to watch Bundesliga football, soccer, you might have a Sky subscription. You might have a Sky subscription, but still I think you can buy something like a game day ticket or something like that. If Bayern Munich plays in the Champions League, you can buy a ticket only for this day here. Okay, that would be something like mixed bundling here. Yeah, how does it look like? So suppose you have two goods and you have consumers who differ in their reservation prices for the two goods. And each consumer buys exactly 1 unit of a good, provided that the price is less than her reservation price. Now, how many consumers do we have? We have infinitely many. They are populated all over this R1, which would be the willingness to pay or the reservation price for good 1, and R2 would be the reservation price for product 2. So our consumer X, who is located here, has a willingness to pay for product 1 of X1 and for product 2 of PX2. Okay, and what we assume here is that the total willingness to pay for a bundle, when the consumer receives both product 1 and product 2, would be simply the sum. Okay, we just assume, as in a previous example, if this is the willingness, if good 1 is highway to hell and good 2 is close to you, the aggregate willingness to pay is just this 80 cent plus 1 cent, $120. Okay, that's what it is. And of course, we have many, actually infinitely many here. Consumer Y with just different reservation prices, PY1 and PY2. And of course, how many do we have? We have infinitely many, okay, consumers. And now suppose that the firm, they are all over here, okay, in this whole range. We can just draw the example here. This would be just another consumer. And now suppose the firm sets a price P1 for good 1 and a price P2 for good 2. And now I erased my lines again. And now, what do we immediately get? Of course, some prices here for the single product, not for the bundle. And this splits consumers into 4 groups. This group A here, all consumers in group A have a willingness to pay or a reservation price for product 1, which is above price 1, because it's to the right of it. And they have a willingness to pay for product 2, there's a reservation price for product 2, which is above product 2. That's so they will buy both products. These guys here won't buy product 1, but they will buy product 2. These guys here will buy only product 1 here. Okay, all consumers in region D buy only good 1, and these guys don't buy anything. Okay, so that's what we have. Well, I think this is pretty much what I wanted to say here. Now, of course, we look into bundling. Now consider pure bundling. So in our cafeteria, you have to buy both the salad and the main course. Okay, that would be pure bundling. And of course then, this line is just R2 is PB minus R1. Okay, that would be the line we draw here. If this is the price of the bundle, who buys the bundle? Yeah, everyone who has a higher willingness to pay for the bundle, that is R1 plus R2 must be higher than PB. Okay? And the line we drew here was just R2 is PB minus R1. And of course, along this line, these consumers would be just indifferent between buying a bundle and not buying. All consumers in region E would be happy to buy the bundle. Okay? All consumers here would not buy the bundle. Okay? Yeah. Again, we have here our standard. What comes next? And I was too fast. Now all consumers don't buy anything. Now we introduce cost. Remember, our salad was costly to produce for our cafeteria. Okay, the salad was costly to produce, and the main course as well. Okay, but what you see here is, again, I think I have to, consumers in these violet regions. What about them? Again, of course, everyone in the, what is this, red area doesn't buy the bundle. But these guys in these violet ranges, they buy the bundle, okay? Even though their willingness to pay here of these guys up here for product 1 is lower than the cost. What does this mean? If you go to the cafeteria, all these guys in former times, they had to take the salad and the main course, but they didn't like the salad, so that it ended up on their trays when they returned their dishes. And of course, that's waste and that's inefficient. And as a company, you don't want to have this. And the question is, what could you do in terms of pricing? What you could do is just sell a mixed bundle. You both sell the bundle and you sell only one of the two products for those who want only, who have a low willingness to pay for one of the products. Okay, so here, of course, the bundle must be cheaper than the sum of the two products, otherwise, of the two separately sold products. Otherwise, if it were up here, no one would ever buy the bundle. Okay, that's clear. So it must be cheaper. Now again, what happens now if you sell this mixed bundle? Okay, what does this mean? You sell both the bundle and you allow the consumers to sell the product separately. Oops, I was too quick. Consumers are split now again into 4 groups. One group buys only product 1, one group buys only good 2, and one group buys a bundle and the others buy nothing. So these guys here, they will buy the bundle, as do these guys here. Okay, rather straightforward. They have a higher willingness to pay, or they of course, if you have a sufficiently high willingness to pay, it's always better to buy the bundle rather than the two separate products, because the price of the bundle is cheaper or is below. So PB is smaller than P1 plus P2. That's what always holds. Okay, otherwise no one would ever buy the bundle. I think I have to erase that later on, but anyway. Okay, so that should be clear. They also buy the bundle. Nothing changed. These guys still don't buy anything. Okay, but now what is different now is that these guys who previously didn't buy anything, okay, they didn't buy anything because they didn't have a sufficient willingness to pay of the bundle due to the low willingness to pay for product 2 here. They now buy product 1. As do, and here these guys in the blue area, they buy product 2, okay? And now we have 2 regions, these 2 violet regions again, and these guys here, they buy, and I have to erase this here, they buy only product 1 and product 2, as you will see in a minute here. Of course, they would have bought the bundle previously, but now what is clear, what is the utility they get from the bundle? They get R1 plus R2 minus the price of the bundle. What is the utility they get from only, so I speak about region L1 here. What do they get if they buy only product 1? They get U1 is equal to R1 minus P1. Now, what is clear here, probably I go back one slide here, if this is P1, we know immediately as R2 is PB minus R1, we know immediately that if we go up here, this will be PB minus P1, because here R1 here, if we take this value, is just P1, okay, therefore we get R2 is PB minus P1. And so what we immediately know is that R2, this is what we have here, will be lower than in this area, if it's without this line here, will be lower than PB minus P1. But if R2 is lower than PB minus P1, and if we just compare the UB and U1 by just looking at the difference, we see immediately we get R1 cancels out here. If we do UB minus U1, we get R2 minus PB plus P1, and from this condition, we already know that R2 will be smaller than PB minus P1, and therefore this is negative. So the utility from the bundle is lower than the utility from just buying this. So these guys are buying only product 1, and of course these guys in L2 will buy only product 2. And now already you get the idea. If you simply set it equal to cost, you already can extract more profit than you previously had. Okay? I think this is pretty much what I wanted to say about that. So the important point here is who buys only one of the products, who will buy the separate products, the individual goods. Only the guys who have a rather different valuations for the two products. So the guys along this 45-degree line have the same valuation for the two products. The more you are away from the 45-degree line, the more likely it is that you buy only one of the products if we have mixed bundle. Okay, that's what we have. Yeah, that's what I already told you. Yeah, what should the firm actually do? The problem is there is no simple answer. I will get back to this example and we will calculate actually the monopoly solution here in a little bit more formal analysis, but I just want to present you another example to make the idea, the basic logic clear. So what is clear is that mixed bundling is generally better than pure bundling, because you always can start at a bundle price at equal to the price of P1 plus P2, and then slightly decrease it and look whether it's better. So mixed bundling always includes pure bundling. But bundling is not always the best strategy here. So you need to look into each case in detail. And I just want to give you another example where we have these costs in more explicit terms and where we see how it works out here. Here the question is, we have, I think, we have two different goods, and we have 4 consumers, and we have certain reservation prices for the goods. And of course, if I want to pay good or I don't know, whatever you think of what the example should be, if the reservation price for good 1 for consumer A is 50 and for good 2 it's 450, the sum of the reservation price is 500. So again, this could be the stereo, okay? And another consumer who has more even kind of reservation prices with a total of 525. The consumer C is similar, and consumer D is also rather different in the sense that she doesn't care for the good 2. So what should we do now? What is clear, for instance, if you do simple monopoly pricing? It's rather clear. We sell each good at a uniform price. Now, if we sell one quantity, we could charge a price of 450. If we want to charge 2, we can charge a price of 300. If we want to sell 3, we can charge a price of 250, and so on. And what is immediately clear here, I think this would be the optimal prices here: 250, selling 3 units of product 1 and only 1 unit of product 2. This would give us the maximum profit and would give us a profit of 750. Of course, you see that doesn't sound like a very smart idea, given that we introduced pure bundling, and we already know that bundling makes sense. Okay, that's what you see in all restaurants and many other. If you could go to the cinema, they would sell you some bundles of, say, both a ticket entry and entry ticket and say some drink and some popcorn or something like that. Now, if you want to sell bundles, it's clear you can charge 500. Okay, and you can sell 4 bundles. So that sounds like a rather good idea, because here you have a revenue of 2,000. Now, of course, you have to subtract the cost, and you get a profit of 1,000. What was previously the profit? And here you had only 750. So this is quite an increase in profit. Okay, that's what you have. But what you already see here, you sold here when selling this bundle, and that's why I like this example here. You sold the product to consumers D, even though this product 2 has a cost of 150. Okay, and this product has a cost of 100, and still you sell it. So what you immediately see is what you could do is mix bundling. Okay, so how would you do mix bundling? You see these 2 guys here, B and C, have rather similar willingnesses to pay. So we would sell a bundle to them at a price of 520. And the nice thing is, you can sell here good 2 at a price of 450, still consumer A will buy, and good 1 at a price of 450, and consumer D will buy. Okay, so that's what you get here, and your profit will be really almost 20% higher. And that's a good idea. And what you also see here, and remember the Sky Game Day ticket, it's terribly expensive if you don't have a Sky subscription. I apologize to the people who don't watch football, but tonight, I don't know. Tonight, Borussia Dortmund will play, I guess, isn't it? Yes. And I can even watch it on the zone. But anyway, okay. So the point is here. You really make a very good deal. Okay, because you abstract from the problem, or you solve the problem that people who have a very low willingness to pay for the specific product get this product even though the costs are higher. Okay. Yeah, hopefully the idea was clear, because now we just do almost the same, but we just put it in a little bit more formal terms by looking into how Paul Beflam and Martin Peitz presented this in their textbook. You will see it's exactly the same as we just did here. Again, we assume that we have this monopolist producing 2 goods, A and B, at 0 marginal cost. Okay, we have a unit mass of consumers. So this is the only difference. If you look into the next slide, again, we have these willingnesses to pay here and here. Hopefully you can see that well. I just could increases. This is exactly to what we had up there in terms of our R1 and our R1 and our R2. Okay, but here just we assume that the total number of consumers, how do I get rid of that? Yes, the total number of consumers is not something, but it's just 1. Okay, so here this would be 1, the total number of consumers. Okay, so unit mass of consumers. And independently, these valuations are independently and uniformly distributed on 0 and 1. Total, why do I say it's a unit mass of consumers? Because, of course, the whole area has a size of 1, okay? And again, we assume this strict additivity, so total willingness to pay is just R1 plus R2. Here it's then just theta A plus theta B. So the valuation for the two different products. That's the valuation for the bundle. And again, we assume that we have 3 different tactics. We have separate selling, we have pure, and we have mixed bundling. And the pure bundling, you will see, is a device to offer a discount. Separate selling is rather straightforward because here, if it's from 0 to 1, this is just a linear demand curve. P is 1 minus Q. And what we immediately know is that the monopoly price would be just 1/2 if we sell it separately. And it would be 1/2 for product A and 1/2 for product B. Okay, and the profit, of course, given that marginal cost of 0 are, if we sell at the price of 1/2, demand will be 1/2, so revenue will be 0.25. And we have 2 different products, so total profit will be 0.5, 2 times 0.25. Now, pure bundling, what you could do is just sell at the same price as you sold this individual product. So just PA plus PB would be 1/2 plus 1/2 is 1. What would that do? It would change nothing. It would give you the same product, the same profit as previously, but the identity of the buyers changes. And that's what you see here, okay? That's what you see here. And that's exactly equal to what I just presented to you. I just increase it here. These guys up here, I don't know whether you can see my mouse here. I don't know. But anyway, so these guys in the, what is this brown area, dark brown or red area, they buy A and B. These others in the lightly shaded area don't buy anything. And we have the buyers of A and B. Whereas if we sell at the price of 1, we have the group on the northeast, who will buy the bundle, and in the southwest they don't buy anything. Okay? Immediately or identical to what we have. Now, what the interesting thing is now, what happens, which price do you want to charge? Is this monopoly price the optimal price also if you sell the bundle? Of course, it's the optimal price if you do separate selling, but if you sell the bundle. So Paul and Martin do some things here, playing around with what changes if you reduce the price slightly, how much consumers will you be able to attract. This is rather tedious. I showed you that in more detail in the notes. The point being here that, and that's what you see from the size of these shaded areas, you attract more consumers if you sell a package, because here you have all along this diagonal who will increase the profit, whereas the demand, whereas here you have only these guys here, and this has a total length of 1, whereas this has a length of a square root of 2. Okay, what I want to do rather is just to, as always, to derive demand curves. Okay, suppose you charge a price for the bundle of PAB, similar to what we did after there. What is then your demand if you charge a price of PAB? You know, if you charge a price of 0, demand will be just 1. This would be this whole rectangle. But now if you charge a price of PAB, demand will be the whole rectangle minus this triangle. But this triangle is simply then, the range of this triangle is simply PAB, this is this here. Then, of course, as the slope is 1, or minus 1 actually, it would be times PAB divided by 2. It's just a triangle. So this would be the share of consumers who don't buy. So demand would simply be, Q would simply be 1 minus this share. Okay, hopefully it's clear, and that's what is written down here. So here, this is nothing else than our demand. This is the mass of consumers which with the willingness to pay for the bundle which is greater than price of the bundle AB. And of course, then the profit, given that marginal cost are zero, is just this quantity times the price. Okay? And now we are happy. As always, we have a demand function. And therefore, we have a profit function. And what we just can do is just take the first derivative or the derivative with respect to the price and solve for the optimal price. And I don't do it right here. You see here you will get something which is cubic. So that's why you get a square root here. And actually, your price is square root 2/3. And this is about 0.82. Okay? And you see, and that's a nice thing which Martin and Paul illustrate by means of these shaded areas. If you sell a bundle, you have an incentive to reduce your price below this monopoly price if you sell them separately. And what does it mean in terms of profit? Your profit increases. Okay, what you just do, you have here the price, you know what you get at this price here, you just substitute that here, and you get a profit of 0.544, which is an almost 10% increase in profit. Okay, that sounds like a rather good thing. If you get by a certain pricing or bundling strategy at 10% increase in profit. So what you have, if consumers have heterogeneous but anchorated valuations, you see the important point is that these consumers are heterogeneous. You have some who have high willingness to pay for good 1, but low willingness to pay for good 2, and so on. And what you get is that you can you really make use of these higher aggregate willingnesses to pay. And so if you have this situation, a monopolist increases its profit under poor bundling compared to separate selling. It increases its demand by selling the bundle cheaper than the combined price under separate selling. And of course, in terms of welfare, that would also be a good idea because more people buy. Okay, now what we introduce next is the mixed bundling. Now you sell both, and this is exactly the same kind of diagram what you see here. This diagram, which is again very small here. This diagram is exactly the same diagram as the one we already discussed here. Okay, it's exactly the same diagram. And what the nice thing is, of course, again, what we do once we want to analyze that formally, we just derive the demand functions. Okay, or demand as a function of price. And what you already know, this, or whatever this is, ochre or brown ranges here, where you only buy product B. This is simple a rectangle, okay, and here as well. And the simple rectangles are just remember up there it was price of the bundle minus price 1. Here it's just the price of the bundle minus here. Actually, I didn't tell you that what we do is, of course, as everything is symmetric, we assume that we charge, if we sell goods individually, goods A and B, we charge the same price for the two products. Okay, and now it's just these rectangles. The rectangle here is just here the length is just 1 minus P. Okay, 1 is the total number of consumers, here is the price, and if we have the price B, here this length will be just PA B minus P. Okay, so this is this range, so this is demand give as a function of the bundle price and of the price for the separate product, which this will be the demand for the individual products. Of course, the demand for the bundle is just these gray area, and again what you can do here is just calculate these rectangles and triangles. Here what you see is we go from 1 to PA minus B. Okay, so this is this length here. So what we do here, we calculate the full rectangle minus, which is then actually this triangle here. That's what you're doing. Anyway, you can calculate it however you like. The important point is you get demand functions. And once you get demand functions, you just set up the profit. Of course, here, what you would do is you would maximize your profit by choosing P and PAB. Okay, you assume that PA is equal to PB. The individual prices, actually this will be a result anyway, as everything is symmetric here. But what you get here, once you solve that, and hopefully we have a problem on that, I don't even know, what you get is that the price will be 2/3 of the individual price, and the price of the bundle will be 0.86. Now this is really interesting because now the bundle gets slightly more expensive than previously, because you can serve these guys with the low willingness to pay for one of the two products with your separate products. They have a rather high price. Remember that the monopoly price was 1/2. Okay, this is well above the monopoly price. That's the really interesting thing if you sell it separately. Still, you increase the profit. However, the increase in profit is comparatively low compared to the case of pure bundling. So, mixed bundling allows the monopolist to increase its profit even further than pure bundling. Here the bundle is more expensive than under pure bundling, and individual components are more expensive than under separate selling. More expensive than a monopoly price. That's rather interesting. In terms of welfare, it's clear that consumer surplus is higher under pure bundling because the price is in a sense lowest. Then mixed bundling comes, and then comes the separate selling with the monopoly price. In terms of welfare, pure bundling is better than mixed bundling because you have lower prices. Okay, and given that marginal costs are assumed 0 here, this would be the natural result. Okay, and because the point here is you have then many people, even these guys here in these ranges, they get only one product, but given that the marginal costs are 0 for this product, it would be good to give them the product as well. But of course that changes as soon as you introduce production costs for these goods. Then you might have a rather different case, as we just showed you. Okay, yeah, that was pretty much our bundling analysis. What we can do here is some rather nice extensions here. The first would be that we have some interrelated products. So suppose these two products are not independent products, but they are either substitutes or complements. An easy way to formalize that would be to add such a parameter gamma here, where gamma is either positive or negative. If gamma is negative, the sum of the reservation prices would be smaller than, the valuation of the bundle would be smaller than the sum of the reservation prices. It's clear if they're perfect substitutes, for instance, you would just assume that the sum of the reservation prices, if they're homogeneous, would be just twice as high as the valuation of the bundle, because you care only for one thing. Okay, if it's homogeneous. Okay, and if it's complements, it's of course higher. You only care for, or you only care highly for product A if you also get product B. The result here, which we don't want to derive, is that the advantage of pure bundling over separate selling tends to decrease as the synergies between the two products become stronger. What does this mean? Suppose gamma is very high and very positive, then anyone will buy anyway both products, so it doesn't matter whether you sell them as a bundle or not. Okay, so it doesn't matter. That's simply the point here. What is more interesting is these correlated values. So what we previously had is that pure bundling improves the profit over the separate selling when we had two products which were independently valued, but where we have, that's really important, where we had heterogeneous consumers. Okay. But we couldn't say that if we have a consumer where willingness to pay for product 1 is high, we know that product 2 has a low willingness to pay. That's different. What we look into now is if we allow for some correlation. So what we do here is just assuming that theta b, the willingness to pay for product B, is some convex combination of theta A, where the convex combination is the parameter rho. What does this mean? Theta B is rho times theta R plus 1 minus rho times 1 minus theta A. And if rho is 0, that means theta B is equal to 1 minus theta A. So if theta A is 1, is very high, we know if you have a willingness to pay for product 1, for product A, you have a 0 willingness to pay for product B. If you have rho equal to 1, we would just simply have that theta B is equal to theta A. That's what I draw here, okay? Rho equal to 1, it's just a 45-degree line. If you have a willingness to pay for product A of 0.2, you have a willingness to pay for product B of product also of 0.2. If you have rho equal to 0, that's this negative correlation. If you have a willingness to pay for product B of 1, you have a willingness to pay for product A of 0. And that's where you get these, in a sense, diagonal, this curve with the slope of -1. And of course, here I drew several other parameters of rho. What you see here is that this is really a rather specific or peculiar specification of this correlation, because if you assume that rho is equal to 0.5, you see that the willingness to pay for product B is always 0.5, and it's independent of theta A. Okay? And that will have consequences because, yeah, now you see when bundling makes a sense. I have to erase that. If rho is equal to 1, bundling doesn't matter, because if you sell a bundle price, you can equally at 0.2, you can equally say you sell the price of product 1 of product A at 0.2 and product B at 0.2. Everyone will buy. You have exactly the same consumer. So no advantage to bundling. Whereas if you have rho equal to 0, this perfectly negative correlation, you see you can just charge a price of 1. Remember, it's still the maximum willingness to pay of 1. A monopoly price would be 1/2. You can sell everything at a price of 1 and you get all consumers. Okay? And the other thing is, if you have this point of 1/2, the bundle is a bad thing, because then you have to make sure that if you sell it at a price of 1, you only get these guys here. If you sell it separately, you can choose product B at a price of 0.5, and you get that everyone buys. Okay? So you really would get a quantity of 1 times 1/2. This is already more than or as much as the monopoly profit in the previous case. And of course, you could sell then your product A at a price of 1/2, which would be the monopoly price. Hopefully, this is somehow clear. This is summarized here, where we have rho, and here we have the profit you make depending on whether you bundle. This would be the bundling profit, and this would be the profit when you sell separately. And what I told you already, if you have this negatively correlation, you can extract all consumer surplus and make a profit of 1 with poor bundling. With perfectly or with perfect positive correlation, bundling and separate selling gives you the same. And here, this is this 1/2 where it's better to sell separately. Okay, profit are higher under poor bundling than under separate selling if and only if the correlation between the values for the two products is negative or sufficiently weak if positive. So here in this range here, okay, up to 0.38. Okay, So there are so many. Unfortunately, I'm running out of time, so I would take another 5 minutes if that's okay, because it's so interesting here, of course. The formal analysis, if you look into a larger number of products, the interesting thing is that if you sell only 2 products, if you sell a bundle of 2 songs, it's rather likely that you have people who like the one and don't like the other. But if you sell them 20 songs, what happens then? If you sell them 20 songs, it's rather likely that you will have, or it's rather unlikely that you will have, say many people who don't love 19 of the songs. Okay, that's like with flipping a coin. If you flip a coin only 3 times, and 10 different people flip this coin 3 times, it's rather likely that you will have some people who always get coin, or who always get head, or who always get tail. Okay, but if every one of them flips this coin about 100 times, it's rather likely that they will get heads and coins about 50 times, maybe between 40 and 60, but you rather won't have anyone who has no heads or no tails. And that's what you can also show in terms of this diagram, where here you have the quantity, and here you have, in a sense, the willingness to pay for the bundle. So this is the average willingness to pay. And if you have only one product you sell, you see you have this rather straight line. Whereas if you sell a bundle of 20, your demand function is rather elastic. Okay, that's what you can see, and that's what you see. You can then sell at a price like this here, and you can extract almost all the consumer surplus. Why is that so? That's like the law of large. That's actually on the next slide. Like the law of large number. If you have here, remember, for the song, your willingness to pay is distributed between 0 and 1. So the mean would be 1/2. If you have 1,000 songs, your average willingness to pay will be about 50 cents. Okay, even though you might have some songs which you don't like, you will have many songs which you like very much. So if you have 1,000 songs or even 1,000,000, your average willingness to pay will be rather close to the mean, actually. Okay, and therefore, the more products in your bundle, the flatter, and that's what we say here, is this willingness to pay, in a sense, this demand curve. Okay, and actually that's very similar for those of you who took economics of regulation to these rent reducing effects of joint production. Okay, but this effect is what you see with the Spotifys and the Netflix, and you see that also with Elsevier, which is a famous publisher, in particular in terms of journals, of scientific journals, where you have many different products in their packages. Same with software. They put as much in these bundles as possible. So as more, the point is, as more products are included in a bundle, the demand curve for the bundle becomes flatter, and therefore this tends to reduce consumer surplus, because you can more easily extract consumer surplus. But of course, it also is rather efficient, because you get very close already to personalized pricing, to price discrimination of degree 1. Okay, very efficient. Okay, so I'm still not really done, because I think I have 2 more or 3 more slides. So I would take these other 2 minutes. So what we see here, or what we discussed in some detail, is bundling. And it works as a price discrimination device. You really make use of these differences in willingness to pay for the different products, and you use the aggregate willingness to pay. Okay, and typically it's a good thing for you if to use bundling if the valuations are negatively correlated. What about tie-in sales? Actually, I don't need to talk much about tie-in sales because that's what we discussed at some length in this two-part tariff example. Okay, because these tie-in sales help to differentiate or discriminate between users who have different demands. Okay, that's what we discussed last week. Another point in this relation in bundling, or a point or an argument which provides, or say a setup which provides an argument for bundling, is that you might have complementary goods. So why should Microsoft sell both the Windows operating system together with the Office suite? Yeah, because it's better to produce them together. It's cheaper to produce them together because they can better make use of the interfaces and so on. Complementary goods, nuts and bolts, and PC monitors and computer processors, or what is called the Wintel monopoly, this would be Windows and Intel, is just complementary goods. Complementary goods are very similar to upstream and downstream goods, to vertically related goods. And it's the same problem. What matters here is what is called double marginalization. I don't go through the details here. I never go through the details here in that respect. You can see that on the next pages, but it simply tells you that in terms of Wintel, if you have these kind of complementary products, like if you remember your Micro 1 class, here you have good 1, here you have good 2, it would be just an L-shaped indifference curve. So this would be utility, an L-shaped indifference curve. If you have something like that, it's a good idea to produce that within a single firm, because otherwise you have the double marginalization problem. You can see that on the next few slides, but I think I don't go into detail. We do that somehow in economics of regulation. That's why I don't do it here. So finally, to summarize, this is actually really my last slide today. In terms of the complementary products, what you see there is that even though these products are complements, it's not always necessary to really have a merger to monopoly, because you always also can achieve this efficiency by other means. Okay. Like product networks. This is a huge discussion in merger cases where these synergies are merger specific. I don't want to go through the details here. What is clear, you don't have a problem if one of the market becomes competitive. That is, if we don't have a margin in one of the market, because if you don't have a margin, you cannot have a double marginalization problem. Okay, no problem then. But again, the point is here, I don't know whether you would consider a printer and the printer cartridges as complements, and here you run into trouble with the price discrimination device. This is what is mentioned down here. Okay, this allows you to price discriminate, and some consumers may not be served without this profitability. What is interesting here, these complementary products played a large role, in a sense, in the Microsoft case, where you have both the operating system and the application software. The problem there is that you have network externalities in that market, and therefore if you allow these complementary products to be offered by a single company like Microsoft, this company might try to extend its monopoly power by, for instance, trying to keep out other companies who might endanger its monopoly position in operating system. I don't have the time to go through here, but it's just here to give you some idea about or what the relevant questions are. It's really troubling, because both bundling And these tying arrangements might have positive or efficiency effects, so they might increase efficiency. At the same time, these tying arrangements might serve to foreclose competition. So think of Volkswagen. Who made it impossible for rival, say garages to get the spare parts and to also provide the repair services. Okay, so tying arrangements might foreclose competition and therefore allow the extension of monopoly power. It's terribly complicated, but that is very good news for economists, because that's why antitrust authorities and also companies always need economists as consultants. This might be a topic for a seminar, but anyway, if you want to write a thesis on that, this is a complicated issue and still probably under research. If you want to have more details, look into Peppel, Richards, Norman here. Okay, it was, I think, chapter 8.3, and unfortunately I had to use a little bit more of your time. Hopefully that was okay. I thank you for being with me, and I'm available for some further questions in WebEx. See you next week. Bye.